Hey, so yeah, welcome everyone to today's Expert Talk Online. Great to have people joining us today. I'm Liz Leakey. I lead our design service at Equal Experts, which covers everything from user experience design through to product and product strategy. And we're joined today by Simon Skelton from John Lewis and Chris Rutter from Equal Experts. Now, while Simon and I have never worked together, I do know that, as I said earlier, he's a fellow Northerner, a proud Yorkshireman, and also very passionate about John Lewis partnership. I think you've been there, what, 21 years now? Is that right,
Yeah,
Simon?
new boy of 21 years.
Yeah. So, and when I've asked a couple of people like what it is they sort of, how they've described you, they did say that you're very passionate about bringing people together, about continuous improvement, but also about making the work meaningful. And obviously, as platform operations manager, you're accountable for the end-to-end operations for digital platforms at John Lewis. So Chris is a principal security consultant here at EE, and he might manage risk during the day, during his day job, but it's worth knowing that he once let a friend convince him to cycle a 100-mile bike race with no training at 4 days' notice. So not always Captain Sensible. And when I asked you what you liked about working with John Lewis, Chris, you said the balance between technical excellence and pragmatism, the way everyone communicates and works together so effectively across different teams and perspectives. So that leads us nicely onto our topic today, thinking about continuously securing hundreds of digital services at John Lewis. And I won't spoil your thunder, I'll let you go into the detail on that. For those that have joined, you can add questions throughout in the Q&A along the bottom of the Zoom menu bar. And at the end, we'll have a chance to go through those. You can also upvote them. So if you want to bring the most popular ones to the top, then when we get to the Q&A, I'll be able to see those and put them to Chris and to Simon. So I'm going to hand over to Simon and Chris. Thanks.
Thank you very much, Liz. And thank you all for making the effort at the end of a long day. As Liz said, I'm Simon Skelton, Platform and Operations Manager at John Lewis and Partners, which means my team provide the e-commerce digital platform for johnlewis.com, and I have overall accountability for the smooth running of the website.
And I'm Chris Rutter, so I'm a principal consultant with Equal Experts. I specialize in DevSecOps and secure delivery. So I've spent the last 7 or 8 years helping businesses secure their estates and also helping to resolve some of the blockers that security has traditionally introduced into delivering software rapidly.
And we're here to talk about paving a secure road at John Lewis and Partners. And as you'll see from this image, which I've taken from our last Christmas advert, how do you metaphorically put on your crash helmet to protect from security dangers that are always present on an e-commerce journey? But first, let me give you a little bit of background on John Lewis. Some of you may not be completely aware of us. We're a very UK-centric brand, but the John Lewis Partnership is the overarching brand, and within that, we've got the John Lewis department stores and the Waitrose grocery stores, both of which offer mid to premium goods to our customers. Our heritage dates back to 1864, when John Lewis Senior opened the first store in Oxford Street in London. But on the top left here, it was actually his son, John Speeden Lewis, who believed in fairness and humanity. And he experimented with a different business model, as he thought it was unfair that 3 owners earned more than the whole of the 300 employees. This now means that our 70-odd thousand plus employees, or partners as we call them, we're all co-owners of that business. We all share in the profits when we make them, of course. These strong foundations have still allowed us to adapt and innovate. There's one of our other Christmas adverts there with Eager Edgar the Dragon, and that's the launch of our advert is often called the official start of Christmas, and it was trending on #1 in UK Twitter within 2 minutes of its launch. And our stores there also continue to be updated to meet the ever-changing customer needs, with much more focus on experience and convenience. And as I'm sure we all know, retail continues to evolve and needs to adapt. So last time we presented, and I presented with one of my other EE colleagues, Steve Smith, at the DevOps Enterprise Summit back in 2021. And we talked about operability, and you build it and you run it. We talked about our journey transforming from 12 big releases a year on a monolithic e-commerce platform to which had a large delivery team handing over to a single operations team and all the constraints that went with that. And we moved to around 40 agile product teams where each build and run their own service, and are now achieving around 7,000 deployments a year, which of course enables much better business agility. So just a little bit of context. These are all our services are built upon our paved road digital platform. I'm not going to go into detail about that, but this is based on the concepts conceived by Netflix. This now allows us to spin up a new service in less than an hour with simple config-driven Google Cloud Platform resource provisioning, standardized observability dashboards and alerts, and much, much more. But we're here today to talk about the next part of the journey, how we've transformed security by solving common technical, organizational, and process challenges. And I'm very relieved to say that just last month, we won the best implementation of DevSecOps at the Computing DevOps Excellence Award. Obviously, I'd have one slide less if we lost, because I wouldn't have mentioned that then. But how did we start our security transformation journey? Well, what was important to me was to understand the different perspectives of the key stakeholders in our organization. So for myself as platform owner, how do I ensure and prove all of my systems are secure? For a product owner, how do I know when to prioritize effort on security? For the product team, how can I quickly build a new project and release to customers quickly? For the information security team, how can I make sure that we have assurance for every single deployment? I'll now hand over to Chris to talk about the landscape we were working with and how we went about tackling the challenges.
Thanks, Simon. So if we look at this diagram, this expresses our workflows around about 3 years ago in terms of delivering software and how we interacted with security teams and how we secured those deliveries. So if we look at the impact security had on those deliveries, if we look, we have a typical kind of product inception. We develop and deploy systems. We're looking at over, in this case, a 12-week period. We'd interact with security teams by kind of letting them know we'd started a project right at the beginning. And once we were ready to deploy, we'd done 3 months worth of work. What would happen is we then start in anger, the risk assessment process. Now you see the kind of 4 arrows there, that signifies a lot of backwards and forwards. You know, this is what I built. Okay, I'll tell you if it's secure or not. This is another thing I built. Okay, I don't understand that. Can you give me more details? Lots of email-based workflows and a lot of kind of backwards and forwards. We then have a pen test. And then after all of that has occurred, we then try and fix any of the pen test issues. And then we'd also try to implement any of the security controls that were recommended as part of the risk assessment. So you can imagine that that period was very contentious. You know, the project's it's already late. And it often took up to 6 weeks, which actually ended up being sort of 50% of the actual overall delivery time for the project, for the product to reach customers. So obviously that has a huge impact on delivery. And also in terms of security, once this risk assessment and pen tests has been carried out, it's very difficult then to secure the system throughout its lifetime. You know, we can't do a pen test every month on every system. And it's very difficult if every team is getting bespoke security advice on each project and we have 40 teams, how do we then react to threats that are emerging? How do we then change how 40 different teams have implemented a certain security control? So very difficult to scale, a huge impact on delivery. And that was the kind of basic challenge that we had that we kind of worked on over the last 3 years. So when we look at that box that I mentioned had a lot of backwards and forwards, we've only got 4 lines there on the overall diagram. This is an actual diagram showing the full process. Now we don't need to go into too much detail, but you can see every single one of those lines there is a communication point, and every single one of those different color boxes at the top is a different phase in this process. So just taking a visual look at that, you can see why it might have taken 4 to 6 weeks for this exercise to occur. One of the engineers, one of the quotes we had is that we spend 75% of the time finding out what to do in terms of security, and then 25% of the time actually doing it. What this actually did is it prevented us from pursuing the strategy we wanted, which was to break up some big monoliths that we had and have a much more composable architecture. And what it did end up happening is that we would have, like we said, 40 different teams all getting the same security requirements and implementing the same security controls in different ways. So you can imagine how much effort was spent that was unnecessary on each one of these exercises. So the way we tackled this, this problem is we basically looked at all of the different security requirements. We did some analysis and we thought, okay, what are the different architectural requirements that are coming out of every single risk assessment? And which of those things can we fully standardize? Which of those things does not need to be different at all for all of the teams? Indeed, which of those it's actually desirable for them all to be the same, because then we can reason about the security of those things. So we're looking at things like secret management, identity and permissions, and things like logging. So we made sure they were very standardized. Platform teams built capabilities for teams, and they just get those things for free. Fully standardized, everybody does it the same, but you get it for free. We then had, some components which were a little bit more bespoke for teams, but which we still wanted to have overall standardization and provide security controls for free. So things like API gateways, queuing infrastructure, or databases, where we want to control how the instances are built, for example, or how the APIs are secured. But teams can then customize the actual API endpoints or customize database schemas. And then right at the bottom of that scale, we have, we want full innovation. We want teams to have full control over every aspect of this part of the system. And that's things like the microservices or the Docker images that they deploy, where we allow full customization, full innovation. You can use the latest technologies, the latest patterns, and the platform teams, will not attempt to standardize that at all. What this resulted in, so this YAML that you can see on the left there, that is literally all it takes on the John Lewis digital platform for a team who wants to get 2 microservices with 1 line of code deployed into production with cross-cutting standardized security controls. So all you need to do is put a name of the product, a Slack channel, the name that you want your GCP project to be called. You define 2 microservices, which language those services use, and which permissions that those services need for cloud resources. Within 10 to 20 minutes, an automated pipeline runs, and basically you've then got 2 microservices that can be deployed to production, and everything on the right there, all the identity and access, all of the ingress, secrets management, logging, are all done for you for free. You don't have to build any of that. They're all done in a standardized way. And you also have communication linked through a Slack channel followed by a convention. So you'll get your own Slack channel based on your team name that we can send security alerts and vulnerabilities to. So basically on day 1, you get a lot of the security controls that previously would have taken 4 weeks to negotiate and implement. Now, the impact this has on the risk assessment process. So if we look at that, the box we had earlier on with all of the arrows on it and the huge complex flow, we now have the ability to just tick a box. So the security team ask us, so how do you manage identity and access on your new product? Well, we tick a box, it's platform provided, that's the end of. It's already been approved, we know it's secure, the team got it for free. There's absolutely no further security kind of backwards and forwards required. And that's the same for all of the standardized capabilities that we provide to teams. So this saves us, between 2, 3, 4 weeks on most of the risk assessments that we carry out. It reduces the amount of time that teams spend duplicating the same security controls. And it's more secure because we can easily prove across all of our systems that we're doing secret management effectively, that we're logging all of the right things. And also, if we have emerging threats or we need to build out new security capabilities, it's much easier for us to update them in place because we have pipelines that manage all this stuff. We don't have to go back to a team and explain, well, actually what used to be secure is no longer secure. And we need you to create some tickets to change it and times that by 40 or 70 or 100 teams. So you can imagine the difference in kind of effort and duplicated work that we've avoided. Over to you, Simon.
Yeah. Right, so we've shown the improvements with the platform provided services, but what about the application security? So 3 years ago, just pen tests at the end of the development meant we were only finding vulnerabilities just before we were about to release, which then obviously impacted delivery timelines. It also meant that we might do months of coding, but only time box a pen test, which could mean potential security gaps. And pen tests are only a point in time. And as security risks surface all the time, so this approach didn't provide the best assurance for the whole life of the service.
Okay, so if we've looked at, the first thing we tackled was these big kind of architectural controls, which we were able to standardize, using pipelines and using convention. What about the things at the bottom of the diagram we showed, the microservices that teams are building, where we want to have full customization and allow innovation? So the image on the left there is just a snapshot of some of the technologies that are in use. When you encourage teams to innovate, they tend to use a lot of different technologies, and especially in the front end space, these technologies change very rapidly. So the standard way to approach this, an effective way to try and scale out security reviews across lots of systems, lots of technologies, and lots of teams. We can't have an army of security specialists, one for each team, because I don't think that many exist and it just wouldn't work. So typically what we do is we look at code scanning. So we implement code scanners that might scan source code, might scan cloud resources, and might scan artifacts for vulnerabilities. And we try and scale out using that. So every line of code, every new library can be scanned, and we can get some security input on all of those things. So basically, if we look at all of those technologies, what might end up happening is we might end up with 10 different scanning tools. And a lot of the enterprise tools in the market, they provide a lot of features, and often the licensing models are quite prohibitive. If you have a microservices architecture, you might pay per application. We've got 400 microservices. That's a lot of money. And also a lot of those tools provide lots of different capabilities that might be duplicated, like user interfaces or APIs. So basically, how do we plug together the results of all these different scanners that we might require? How do we provide engineers with a single pane of glass so they don't have to log into 7 different systems to understand any vulnerabilities they have? And how do we do all of this without spending a large amount of money on licenses and contracts with different scanning tools? So the approach we took, we've coined it as bring your own scanner. And the approach we took is we basically went we didn't start off looking at tools. We started off looking at requirements. So we said, okay, if we categorize the different stakeholders in these security scanners, we have engineers, we have delivery leads and product owners, and then we have business owners and InfoSec teams. So what do they actually need? What value can they get out of these tools? So if I'm an engineer, I want fast feedback, I want minimal false positives, and I want easy onboarding. I don't want to spend a week getting a scanner to work. If I'm a delivery lead or a product owner, all I really want to know is how secure is my product? And when do I need to invest time and effort in fixing security issues? If I'm a business owner or an InfoSec team, what I really want to know is across the whole estate, are we secure? Are we trending in the right way? Can I prove that in an audit condition? Can I produce a report that says all of my systems have these many vulnerabilities and we fix whatever we find? So we found the hardest part about using a lot of scanning tools was trying to get those requirements for the delivery lead, the product owner, the business owner, and trying to plug together all of these different scanners. Like we said, they all have different APIs, they all have different UIs. How do we plug them together? And also, how do we map them to how we work and how our systems are set up? How do we integrate our user model? How do we integrate our communication channels? How do we allow engineers to be notified when they have issues? So rather than try and plug together all of the different tools, we basically built our own set of security dashboards and a kind of a database that backs that up to meet all of those requirements. And now it means we can easily plug in much more lightweight scanners that are often CLI based and easily plug them in with minimal effort into the dashboard system that provides all of the benefits that we need for the delivery lead, the product owner, and the business owner. So here's an example of, this is a screenshot from one of our dashboards. So this is the view for an engineer or a product owner that shows the security posture of a particular product. So basically this takes an input of, I think at the moment we have 7 or 8 different scanners, which feeds into this dashboard. So we have static code analysis, we have cloud scanning, we have scanners which scan GitLab source repositories for leaked secrets, and all of them go into this, this dashboard. So as you can see, there's a very clear security policy now. For example, if you have a critical issue, it must be fixed within 5 days, or that counts as a failing vulnerability. It's outside of the policy we've agreed. It's very easy there to see, it's red or green, fail or pass, whether the product is failing or not. And like we said, all the different scanners are in one place. We can see overall metrics, we can see trends over time, how many open issues are we finding, and how many vulnerabilities are ending up being outside of policy. That's usually the key metric to understand if we're doing the right things and investing the right amount of effort. So basically, we built this using Grafana and using Google BigQuery underneath. It was very easy to build. It took us 1 or 2 engineers a few weeks to build a lot of this infrastructure. And what we found, to be honest, it took less time to build our dashboards than it did to map one single enterprise scanning tool into the way we work and our processes and onboard it. And now if we want to introduce a new scanning tool, because a team would like to use new technology, it's incredibly easy to get a CLI tool or an enterprise tool if that's the right fit, and easily just plug in a feed of vulnerabilities into our dashboards and easily map it to how we work and to our domain. So also one of the key things with, we've got the dashboards, we've got the information there, but one of the key things to get value out of scanning is to help allocate ownership, is to make teams responsible and encourage them to be responsible for the security of their own systems. It's not just a big pot of vulnerabilities, which you might look at once every few weeks. You should be notified as soon as you have issues, and you should be notified when your issues are becoming outside of policy. So it was very easy for us to integrate our dashboards with a cloud function, which sends a Slack message every day to all of the different teams in their team Slack channel to let them know exactly how many open vulnerabilities they have for which scanners, and also let them know which vulnerabilities are outside of policy and which ones are almost outside of policy. So you've got a fair chance at fixing things before the team goes red. This also links back to the dashboards and also has a set of runbooks so a team understands exactly how to triage a vulnerability and exactly what to do if they have a leaked secret or if they have a vulnerable third-party library. So we've seen this have extremely positive impact on remediation trends as teams really feel kind of responsible for their own security. It keeps engineers engaged with fixing these things, and it avoids what might have happened in the past, where somebody has to get a spreadsheet of all of the vulnerabilities and the whole estate and spend weeks tracking teams down and owners down and saying, can you fix these? You've got 600 vulnerabilities, please. All of that disappears and the teams own the vulnerability management themselves.
So we've shown how we've provided security visibility at a product team level, which leads to less delay fixing pen test issues raised late in the development cycle. This means we can securely release features more frequently to customers, which is what we're trying to achieve. We also have better assurance of security throughout the lifetime of the service too. And finally, we can also provide an export from our security scanner to provide the visibility and assurance to our information security team too. We've also integrated this into our senior leadership team service reporting as well. So as it says at the top, security, while it's not quite front and center, it's more top right, but you get what I mean. Alongside our key availability, website performance, DORA metrics, we've also added a high-level view of the security vulnerabilities which are outside the policy. This helps prompt the conversation and aid support for prioritization where we need it. And we can easily dig into more information with our high-level vulnerability dashboard, as you'll see here. So this is the higher level to what Chris showed earlier. This lists all the services we're running on the platform. Clicking on any of those services drills down to the dashboard that Chris showed earlier. We can choose to sort by those that are with most outside of policy or those with the most critical vulnerabilities. It also shows average age of vulnerabilities, which allows us to have the right conversations with each of those teams as to what is the circumstance, why are they struggling to prioritize that work? And we can also select specific scanners, such as the secrets auditor or image vulnerabilities, if we wish to drill down. And as Chris showed earlier, the charts also allow us to review the security position over time and to spot trends. But what about critical emerging threats? Well, I'm sure many of you will be familiar with a Log4Shell, which emerged over a weekend in December 2021. I remember sitting in bed getting a message from a senior member of one of our consultants going, what about this most critical vulnerability of the last decade, as it was reported on? At which point we started running around, contacting every team to see if they've got any affected services and filling out lots of spreadsheets to track the risks and actions. So whilst our response, particularly in the e-commerce team, was quite swift, it required far too much manual effort and therefore drove the creation of a bill of materials dashboard, which Chris will now discuss.
Yeah, so I mean, I'm sure a lot of people on the call went through the same issue Simon just went through. So what we did is we built a bill of materials dashboard as well. So every few hours, we have a set of cron jobs, which basically scan all of our Docker images. So they use a tool called Sift, which fingerprints every single operating system package within the container, and also scans for any application code libraries, so any Java or Python or any other language, and builds a bill of materials and sends it into our central database. What we then do is we also cross-reference each image with what's deployed in production. So it will only appear in this dashboard if the thing is actually deployed to prod. You know, if you're trying to scan source code for these vulnerable libraries, it's very difficult to understand what's actually deployed and what isn't, and just adds time to your response. So using this library, basically, you know, within seconds, we can search for any type of artifact, the name of the artifact, like log4j core, any affected versions that we know are vulnerable, and basically within 10-20 seconds, we can get a list of every single team, every single microservice, whether it's deployed into production or not, and where these things are being used. So now you can imagine how hard that was before, trying to rely on static analysis, or, you know, trying to furiously write a script to do this, or trying to get in touch with all the different teams over Slack. We can now do that in seconds. And it takes usually now less than an hour for any teams that we know are vulnerable for us to just easily take an export of this list, send a message on Slack, and get them cracking on remediating the issue. Another benefit is that it's actually difficult to figure out who's fixed the issue and who hasn't. You know, if you're dealing with a spreadsheet, you might have 100 different teams. You have to get in touch with them all manually and say, have you fixed it yet? Now it's incredibly easy for us within a couple of hours notice to know exactly who has fixed it, who has deployed to production, and who hasn't. So this has saved us hundreds of hours of effort when dealing with, you know, a critical vulnerability like Log4Shell. And actually, it saved us a lot of disruption because we only have to disrupt the teams who actually are vulnerable. You know, we don't have to press the big red button and ask every single team on the platform to investigate, are you vulnerable to this thing? You know, we only communicate with the teams who we know are vulnerable. So yeah, it saved us a lot of time and effort. And again, because we're using Grafana, because we're using you know, lightweight tooling, cron jobs, cloud native tools, it took us, you know, less than a month to build this, maybe 2 or 3 weeks to build the whole thing. So incredibly useful, considering the amount of effort we had to put in. So what's next? Obviously, you know, security and any kind of building software, it's a constantly evolving thing where you have to update and add new features. One of the things that we'd like to do is to, you know, select some more scanning tools and add some more. You know, there are still some new frameworks and technologies that we'd like to add better scanning for. And we'd also like to calibrate the rule sets for the scanners that we have to either add, you know, more intensive scanning or even further reduce the rate of false positives. One thing we found when scanning for vulnerable third-party components is often, you know, if you scan any kind of Linux image, you get a lot of vulnerabilities, and you get a lot every single week or every single month. Now, we know that not all of them, even if they have a high or critical severity, not all of them are actually high or critical, given where they're deployed, given whether they have internet access. So we're looking at building a more realistic severity scoring and adding things like, the deployment pattern, or whether the vulnerable component has internet access, to again reduce the impact that our teams have when dealing with vulnerabilities. And the last thing that we're actively pursuing is, we love how teams own their own vulnerability management. We'd like to get the same thing with dealing with real-time security threats. So things like from our security operations center, when we have suspected real-time security threats, if somebody trying to compromise an application or compromise a cloud environment, we'd like to have those alerts go straight to teams over Slack as well, rather than having to go through a central function and then having all of these communication channels backwards and forwards. So that's what we're working on next at John Lewis.
So to sum up, how do you secure over 700 microservices with daily deployments to production? Well, we recommend sharing security responsibility across the different teams and levels within your organization, and create effective reporting and communication to engage them in a way that's relevant to them. Be opinionated and standardize key security areas to drive consistency and to save reinventing the wheel. And know also when to be unopinionated and provide extensible capabilities to allow innovation, but fold that back in if it's of value to others on the platform. Also understand the security requirements for all stakeholders up front. Build workflows to support their different perspectives and needs. And think very carefully about what you want to build versus what you want to buy. Often a lot of effort can be spent mapping a bought tool to your domain. So consider building your own reporting and the management glue. So that brings us to the end of our talk, and I hope you found at least some of it of interest and relevant. And thank you very much for listening.
Thanks, Simon. Thanks, Chris. That was very enlightening. As someone that works more in the user experience space, I feel like I learned something there, so thank you. We've now got a chance for everyone to ask some questions. I'm sure you've all been really listening hard and not actually had a chance to add any yet. So, but we have one here from Nick Silver, who I can share. So please, can you give an example of a security policy that you might scan for and what it means for something to be inside or outside of that policy?
Yeah, I can pick that one up. So, I mean, when we talk about policy, we really wanted to make the overall security policy very simple. So at the moment, we just base everything on severity. So if it's critical, the policy is you should fix it within 5 days. If it's high, you should fix it within 30 days. And if it's a medium, you should fix it within 90 days. Now, the key part then is, I think your question is after, is how do you then map the results of all the different scanners that you have to those severity metrics? So some examples, I mean, we have a scanner which scans for leaked secrets in our GitLab repositories. So we made the decision, and all this was transparent and the teams can understand these decisions. We made the decision that a leaked secret is almost kind of it's like a half security incident. It's not just a vulnerability in code that could be exploited. It's actively putting us at risk. So every single leaked secret we have is either critical or high severity. So if we have a leaked secret which deals with cloud credentials, for example, it's always critical. And if we have a leaked secret which deals with something like an API key, which should never be used as a primary authentication mechanism, then we put it in as a high severity issue. We then have other static analysis tools. Generally the findings come with severity. The same with like cloud security posture management. When we're looking for cloud misconfiguration. Sometimes we put our own mapping in between. If we feel that what Google thinks is critical isn't actually critical for us, we might have a little bit of mapping that kind of downgrades it. We tend to dog food anything that we release on our platform teams who run on the same infrastructure as our service teams. We make sure that we have a kind of a contract with the teams that we will not introduce a scanner that is going to inundate you with 1,000 findings on day one, because it's not fair. So we'll always dog food that kind of mapping ourselves before we release any new scanner.
I like to call it drinking your own champagne rather than eating your own dog food. But but I think, from my point of view, what's really important is to apply your policy for your organization, because we'll all have different tolerances depending on your organization, your commercial environment. And we were able to do that and just simply apply that policy and say within 5 days or 10 days or whatever's relevant for you for a critical alert, and just make that black and white with the big fail up on the screen to prompt action.
Great, thanks. We've got a question from Henry. Is the security dashboard you've built something you would consider contributing to open source?
So that's an interesting question. I think so as I mentioned in the talk, a lot of the difficulty with getting value out of a lot of security tools, it's mapping the findings to how you work, to how you've set up your platform or your teams, how you organize yourself, how you decide you want to deal with findings. Do you use Slack? Do you use Teams? Do you have one team owns one service, or do you have a multi-ownership model? So a lot of that side of things, I think, would be proprietary to John Lewis. And that's where we found a lot of investment was really effective, because we just plug scanning tools in. The other part of the infrastructure is quite simple. We have a Python-based microservice, which reads from a pub subtopic where we submit scans and findings, and it just dumps it all into a BigQuery database. And then the queries on the Grafana dashboard are basically just SQL that query in, and then we've kind of drawn the visualizations ourselves. So I think part of that, the vulnerability service, that would be useful as an open source component. I think that's quite transferable. I think other parts of it, you would always get more benefit, I think, if you mapped it to your own domain. We haven't considered whether we'd open source it or not. I know there are members of the team who love that idea. And yeah, we hadn't really thought about it, to be honest, but it's something I'll raise, and we'll watch this space. Maybe you'll see that soon.
I think it is one worth taking away. I mean, if we think there is value, I think the thought that went into the structure, what you put in there, how you surface it, I think that could be of value to everybody, even if that's just the starter to get you going with the right kind of dashboarding. So, well, I'll take that one away to discuss with the team.
Okay, we've got the next question, which is from Akshay. Will this dashboard tool scan 3PP code vulnerabilities?
I'm going to look really silly here, but I don't know what 3PP is.
Oh, I was relying on you, Chris, because that's all my
Sorry, is it okay, Akshay? Could you give a bit more context?
Yeah, I don't know. Maybe you could write some more for us, Akshay. So.
Is that third-party provided?
Maybe it is, yeah. 3PP, third party, yeah.
Yeah, I mean, I'll answer on that assumption. So yeah, so we use scanners for third-party vulnerable libraries. So we don't try and scan the code itself within third-party libraries, but we do scan all of our third-party libraries against like the National Vulnerability Database, and we look for vulnerable components. So we use a tool called Trivy to do that, which scans our container images and looks for vulnerable operating system components, and also looks for vulnerable kind of Java components or JavaScript in some cases. We're looking at potentially extending our bill of materials application and just using the output of that to scan. Rather than scanning every container image, we just scan the output of the bill of materials. It'll simplify the architecture, and it'll be kind of cheaper to run, and it'll be easier to scale. But yeah, so we do feed in third-party vulnerability scanning into this. Again, it's quite easy. The architecture we have, there's no one tool which will scan, that I know of, which will scan JavaScript libraries, Java libraries, operating system packages, in the way that we deploy them anyway, in the way that we organize them. So it means we can plug them together. We can stitch together npm audit for the front end and just write a simple wrapper that sends it to our vulnerabilities dashboard. We can use, we use a tool called Contrast at the moment, which scans the Java vulnerabilities. But then we'd be open if we needed to use something else. If we can find a lightweight tool that's, that where the costs are acceptable, then we can plug that in as well, and plug it in within a week or two usually.
And I think that's really important to be able to plug in and have that kind of best of breed. I mean, I get contacted by supplier security kind of scanning, companies that will give you dashboards, say we can scan everything, plug it all in, give you this kind of capability, but you're either locked into one vendor or a big price, or maybe it doesn't cover all your needs if you use a particular technology. I know we had a lot of debate on what was the right tool, even kind of using contrast, but that just was scanning one kind of aspect. So I think it's really valuable that you can plug in all these different scanners, and as Chris said before, technology changes all the time, so you need to be able to continue to use the best thing. And for me, being a Northerner, a Yorkshireman, using free tools or cheap tools where they're absolutely good enough is brilliant.
Yeah, and just to add to that, in some cases, like a kind of enterprise tool is the right choice still, because the scanning engine is really, really advanced, and it really does what we need to. It's just that we've kind of separated the idea that the scanning engine's great to all the other bits, which is like, well, can it produce policy? Can it map to our systems? Can we get value as an InfoSec professional? We've kind of decoupled those things, and that's what gives us more freedom to use lighter tools when we need to, but then still use enterprise tools when it makes sense.
Great, thanks. I had a question about sort of the move from 3 years ago to now, where you're asking teams to take responsibility for their own vulnerabilities. And like with any digital transformation, there's often a big change in ways of working and process, as well as anything you do with the technology. Did you come up against any challenges around asking teams to take on that level of responsibility?
I mean, I'll go first. I think it's interesting because those teams always had that responsibility. Did they know they had that responsibility? Did they know what to do about it? Certainly large enterprises and organizations, quite often you have a separate security team. Yeah. Everybody thinks it's their responsibility. Certainly in our organization, they will recommend policy and say you should be secure in this way, but they aren't often the experts and the ones that are really accountable for the security. Certainly they're not, most of them, engineers that can actually make you secure. So it's always been the case that they were responsible. I mean, my team as platform were responsible for the platform security, but not for the code and the microservices built on top of it. So I mean, I'm not saying that some still don't have resistance, that, oh, hang on, a product owner would go, well, that's an IT issue. That's not a product issue, but security is all our responsibility. So what I think this helped us do was make it really visible and bring it up at the same level as product features, as incidents, bugs, defects, whatever you want to call them, and bring it to be the same level of visibility, which means you can make that prioritization choice. You made it easier to go, this is where you need to focus your time. Don't worry about all these other things, or don't worry about engaging with a security team that you don't understand what they're asking you, or even that was your responsibility. So I won't say that everybody just jumps at it, but the dashboard helps us understand the teams that are less engaged. And that's what's really important, having that visibility to be able to engage with them, because normally it's a struggle with resources, or we've got a real deadline for this, and we can have a discussion about, okay, well, you can go outside of policy for a period of time, but then you need to prioritize it and catch back up again.
I mean, it sounded like it's been positive on the whole. So your ambition to sort of move to people dealing with real-time threats sounds, like you've got the majority of people on board. It's perhaps just some of the tension between prioritization that always there, isn't it? So,
I mean, the bill of materials is kind of brilliant, because as we said with Log4Shell, that evolved over a weekend, had to call out nearly every one of our kind of 40 product teams on a Sunday. I didn't want to be calling them, but I didn't know where we were vulnerable. It was it was happening in the moment.
Yeah. And
to be able to have that kind of capabilities now to go, well, don't panic, or I'll call out 2 teams because we think we're at risk there. That's a massive step forward for me.
Actually, Boris has got a nice question leading on from this, which is, I guess, specifically around e-commerce. So did you evaluate what the major security risks are for big e-commerce, and wonder which one tool, like the ones you were building, are addressing, and which ones are out of scope? So I think it's about identifying the major risks for e-commerce.
Yeah, I mean, so we carried out kind of platform-wide risk assessments, and we also carried out our own sort of deeper like technical security risk assessment, and to figure out where were the crown jewels, what were the biggest things that we were scared of as an e-commerce company. Obvious ones like data protection, GDPR, and ransomware, and things that that could potentially have an impact to our customers, like card scrapers and that kind of thing. So that obviously feeds into where we direct our energies. I think the initial idea was we wanted to get coverage of all of our different languages and all of our different estates, and we wanted all teams engaged in dealing with findings for their software. So that, for us, in my experience, that's the hardest thing with kind of security tools and scanning. It's not the quality of the scanner, it's the workflow and actually integrating that with teams and getting them to use it and feel responsible. So we took the approach where we get the scanners all working, we get all the teams responsible for dealing with their own security vulnerabilities, and then we fine-tune, and then we really fine-tune on the riskiest areas. So we'd fine-tune, like we said, on what are the most vulnerable third parties that we really care about. Is it card scrapers? Is it something that could obtain remote code execution and get access to our databases? So we just went initially, we need vulnerability management, we need scanning, and that was the first step. And then the second step has been, let's use our knowledge of the risk in our domain to then refine those rules and focus on what we're most scared of, I guess, or most worried about.
And there's always, for a big e-commerce site, there's multiple angles to security. It's multi-layered. It's not just the scanners and the vulnerabilities. You always have your WAF or your DDoS protection or various different credential stuff in all aspects like that. So all those things kind of built together. This is more focused at the kind of platform vulnerability and security and the code kind of security. But yeah, I mean, for a big e-commerce site, you've got to take it from every single angle, because they will always look for the weakest link.
Great, thank you. So I don't know if we've got any more questions out there. There's probably time for one or two more if anyone else has got one. While I just give people a chance to write anything else, I was just going to finally maybe ask, you've obviously been doing this over 3 years. You must have learned an awful lot in that time. There must be people out there that are actually at the start of that journey and maybe are where John Lewis was 3 years ago. Is there one piece of advice or one thing you would say to sort of help to get going or, start on this journey? Anything that you would suggest or advise?
I mean, I think from me, it's just reiterating the point of consider your different stakeholders and the different needs. So that would be the one thing to start from. Don't just start with a tool that's an answer. Think about what the needs and the requirements truly are to make it as simple as possible for each of those stakeholders to digest that information. Basically, like anything, you only want to deal with the exceptions. Otherwise, you're overwhelmed with it. Security is just never ending in terms of vulnerability. So being able to surface the exceptions, make them really clear for each of those stakeholder groups, I think that's just really important. Work back from there. I mean, it's a classic, do your analysis first rather than jump to a tool. But almost every security vendor will start by, I've got a tool that will fix all your problems. Well,
it's music to my ears to hear you talking about starting with the users. I have a slight bias there. Did you have anything to add there, Chris?
Yeah, I mean, just to add to that, it's kind of it's sort of take ownership. As an engineering team or as a platform, it's very easy to just be annoyed at kind of archaic security processes and see it as just something that's, oh, well, I have to do it. It's red tape. I have to just get it out of the way to do my real job, which is to deliver software. It's kind of like take it on and say, well, actually, security is my responsibility. These workflows, we are best placed at sort of trying to break them up. And certainly with how fast technology is moving, it's very difficult for InfoSec teams to keep themselves upskilled and keep a handle on all the new technologies and workflows that are going in there. So treat it as a problem that you can solve. And like engineering teams are brilliant at solving problems, building efficient workflows, and that's what kind of DevOps is about. So just treat security as the same way we treat operability or reliability, and great things can happen.
Right. Well, thanks very much to both of you. It's been really interesting. And thanks everyone for their questions this evening. Hope you've all found it useful. So yeah, special thanks to Simon and Chris for this evening. And we'll draw it to a close. Thank you.